So, but our last concept, kind of what we're going to be looking at, and this is honestly how you would want to solve different word problems. And I'll kind of maybe talk about this as we're going through this today, just in case, because we probably won't do a lot of word problems. I might put one on your test, maybe as extra credit, potentially even, just so you can kind of see it. But this is really how you would probably want to solve a question like that. So the most important form usually is standard form. Because if you have standard form, you can go to vertex form, you can go to factored form. So if they don't give you standard form to start, like, and I'm asking you to get all three forms, your first goal should be to try and get your standard form, and we'll kind of show how to do that, but not in this first one. So to get vertex form, you're gonna complete the square. Oops, what's happening? I mean, to get it in factored form, you're obviously just gonna, does it keep popping up like that? Give me 1 second. Let me see what the heck is happening. All right, so sorry about that. So to get it in vertex form, you're going to complete the square from standard form, and from factored form, you're just going to factor it. So to complete your square, I'm just going to rewrite what we have in standard form. So to complete your square, remember you group up your first two things, leave a little bit of space. So when you complete your square, remember it's b over 2 squared. So -8 over 2 squared would be -4 squared. So that would be plus 16. So then we have to do the opposite on the outside because we don't have like an equal sign. So we're going to do the opposite. So this would be x minus 4 squared when you factor that. And then 15 minus 16 would be -1. So we really have y equals, sorry, I kind of forgot this is really y equals all this. So our vertex would be +4, -1. If you remember, like it's the opposite of what you have on the inside. Your outside number stays the same. It's like that h in your k. I'm going to probably erase this because it's going to get, I think it's too overwhelming on the eyes. But remember, your h comes from here and your k comes from here. Because vertex form, I'm going to erase this in a second. But remember, vertex form looks like this. So that's like how you pull out your vertex. It's that h comma k. Let me pause. Let me see. There's a couple of. So that's our vertex form. From factored form, like I said, you're going to start with your standard form still. So I mean, for this one, I mean, it's not anything crazy. You want to think what would what would multiply to 15 and add up to -8. So that would be -5 and -3. So this would really be y equals x minus 5, x minus 3. And your x-intercepts or our solutions or our roots would be at 5 and +3. Like those would be our answers, like your so your solutions when you saw those in terms of your graph are your x-intercepts. So oh, and I forgot to mention the one thing you can get from your standard form is your y-intercept. Your y-intercept is always going to be 0, and it's always your c or your constant. So like our y-intercept would be there. So from standard form, you can get your y-intercept. From vertex form, you can get your vertex. From factored form, really what you're getting are your x-intercept, or sometimes we call them our roots, sometimes we call them our solutions. Like we use a lot of different, sometimes we call them our zeros. So a lot of times we use different words, but probably like the simplest or the most familiar should be probably x-intercepts. So to graph, and like I said, if you can't print this off, or like if there's a question like this on the test and you can't print it off, I'm not that worried as long as you write this information like what you found. Because I mean, basically you're just going to plot these important points we found. So our y-intercept wouldn't fit on our graph, but our vertex would. So 4, -1 would be here. And then our x-intercepts would be at 5 and +3. So 3 would be there, 5 would be there. And then, I mean, you could just sketch it. I mean, it's going to look something like this. And the graph, I'm not that worried about. I mean, I just want you to plot those important pieces of information we found. It doesn't have to be super accurate by any means. Okay, so that's really how you're going to go from all three forms. We'll see, depending on what form they give you, kind of like how you want to approach this. But once you really want to get your standard form if you don't have it, because once you have your standard form, you can get your vertex form and you can get your factored form. So getting that standard form is crucial. But let me know, are there any questions so far? Start recording. So for the second example, we have our standard form. So like I said, I kind of forgot to do this at the start, but I mean, basically what we can pull from this is our y-intercept. So it would be 0, 6. Always your C term is basically your y-intercept for these once it's in standard form. To get vertex form, we got to complete the square. So it's been a while since we've done this, but you're going to basically group up your first two parts, but you got to factor out that coefficient of the x squared. So we want to pull out that -2. And that was +6 on the outside. So now we can complete our square. So that 2 on the inside, like 2 over 2, like our b over 2 squared. So 2 over 2 squared would just be +1. But remember, since we have this coefficient, this is really like a -2 when I put that 1 there. So to do the opposite of -2, I would really add a 2 to the outside. So if you have a coefficient in the front, just be careful. That's like when you put something on the inside of those parentheses, it's really not what you're putting. It's what you're putting multiplied by that outside coefficient or that outside GCF. So, I mean, if we factor this down, though, we would have -2 x plus 1 squared. And then 6 plus 2 would be +8. And sorry, I kind of forgot. These should always be like y equals. But our vertex would be -1, the opposite of what you have on the inside of your binomial. And then the outside coefficient, your k stays the same. Okay, to get our factored form, there's two ways you could do this question. One way is you could just multiply -2 times 6. Think about what multiplies to -12 and adds up to -4. And then you could do grouping. But maybe an easier way to do this question is you could factor out a GCF first, like because you can really pull out a -2 from all of these terms. So really you could just turn this into an easier problem. What would multiply to -3 and add up to 2? Well, that would be +3 and -1. So if I pull that out, now I don't have to do grouping because my coefficient is 1 with my x squared. So it would really be -2 x plus 3 and then x minus 1. And then I would just, you could almost just ignore that -2. It's not going to change anything. So my x-intercepts would be at -3 and +1. And like I said, you could then use these pieces of information we got to make a quick sketch. Like, and I know these graphs on this sheet are, honestly, they're not very good graphs. They're kind of faded. But I mean, you could plot your y-intercept, 1, 2, 3, 4, 5, 6. Hopefully I'm counting right. Your vertex would be -1, 8. I don't think that is on the graph. 1, 2, 3, 4, 5, 6, 7, 8. Oh no, it is. It's on the very top. Almost. Okay, but it'd be around there. And then your x-intercepts would be at -3 and +1. So a really rough sketch, it would look something like this, though. But honestly, like when you're doing these questions, like, because I'll put some questions probably like these on your quiz, especially if you're not able to print it off. I'm not that worried about your graph. I'm more worried about, can you get like your three forms? And then can you get like your information out of it? Like, can you get your y-intercept, your vertex, and then your x-intercepts? So, because I mean, I'm assuming once you get those things, you can all plot points. So if you're not able to graph on your quiz, it's not the end of the world to me. All right, let's look at a question though where they don't give you your standard form to start. Like this one, they give us our vertex form. So I mean, I know my vertex, like, I mean, since they gave it to me, I might as well write it out. Oops, let me try that again. Like our vertex would be +7, +1. So now we want to get our standard form and we want to get our factored form. So to basically, you want to, like, if you don't have your standard form, like you definitely want to find that first. So we got to convert this into standard form. And this is something we haven't really done. So let me know how you feel about this. But basically, we got to basically expand this equation. So we have negative x minus 7 squared plus 1. So really what this is, that's negative x minus 7, x minus 7 plus 1. Like if you expand, remember when you square, you really multiply that whole thing times itself. So we got to FOIL this out. But what I would usually deal with is, my advice is probably just distribute this negative sign so you don't forget or have to deal with it later, because this would really just turn this, you would just multiply it to one thing. So it would be negative x plus 7. And then we need to FOIL this out. So like negative x times x would be negative x squared. Negative x times minus 7 would be plus 7x. 7 times x would be plus 7x. 7 times negative 7 would be minus 49. And then the plus 1 would come down. So if we clean this up, this is really negative x squared plus 14x minus 49. And I don't really have a lot of space, but that means, sorry, I can't really squeeze it in, but our y-intercept would be 0, negative 49. So obviously that's not going to fit on our graph. So now we need to factor the standard form. So we really have, I'm just going to write what we just found. So negative x squared plus 14x minus 49. So one tip, if you ever have a negative coefficient, because remember when you factor, if you can get rid of your coefficient, you can usually do it the easier way. If you have a coefficient or an a value that's not 1, then that's where you have to do grouping. But usually I try and avoid grouping as I can. So you could factor out this -1, like basically change your signs of every part in this. So to factor this, what would multiply to positive 49 and add up to negative 14? Well, that would be x minus 7, x minus 7. So my x-intercepts, I would only have one, because I mean, you would get the same answer twice, x equals 7, x equals 7. But what that means, and this one might be a little bit weird to kind of graph on your own, but our vertex is 7, 1. Wait a minute. Did I do something wrong? Here, let me grab my key really quick, because that doesn't make sense. So sorry, I caught my mistake. So I paused the video. So I forgot about this negative 49 plus 1. So that would have been a minus 48 here. So obviously that would have changed here. So this would have been a plus 49, or plus 48, I mean. So what multiplies to 48 and adds up to negative 14? Okay, well, that's going to be different. Okay, so we're actually going to have to. But it is possible to have something like that. That would just mean that your vertex is the only point that crosses the x-axis, but that's not the case here. So what multiplies to 48 and adds up to negative 14? That would be 6 and 8. So -8 -6. So thank you for that catch. So sorry, our x-intercepts would be at 8 and +6. So we would have 7, 1 like here. And if you remember, our y-intercept was like 0, -48. So I mean, it would cross like way down, like down here somewhere. And let me fix that actually. So sorry, our y-intercept would have been -48 then as well. So far, and tomorrow, like I said, I'm kind of similar to this and have you try some to see if you can do it. I'll post that our productive. So let's look at our next one. So this one's pretty similar. They give us our vertex form. We don't know our standard. We don't know our factors. So I mean, the first thing you can, I mean, if you want, you could just write what your vertex is since they gave it to us. That would be 1, +3. So like I said, if you don't have standard form, that should always be your first priority. You want to get your standard form so then you can get whatever form you're missing. So for this one, I'm just going to copy what we had. Let's try not make a mistake this time. Let's see if I can do it. So we want to expand this. Remember, x minus 1 squared is really x minus 1, x minus 1. My advice is just distribute this -3, and it only goes into the first one. But I usually do that first. I mean, you could FOIL and then multiply everything you get by -3, but personally, I think that's easier to make mistakes that way. Let's not get sloppy. That's a -1. Okay, so we're going to FOIL this. So, I mean, -3x times x would be -3x squared. -3x times -1 would be +3x. 3 times +3 times x would just be another +3x. 3 times -1 would be -3. Don't forget to bring down this +3, so that really just cancels. So I don't want to write too big, but we have -3x squared plus 6x. And then if you want, you could put a +0, or basically there's no constant. So our y-intercept, we're going to see, since our constant term is really 0, it'd be 0, 0 is our y-intercept. But we're going to see that's actually going to be one of our x-intercepts, because 0, 0 is a y-intercept and an x-intercept. But so we'll see this one. It's not that important. So to get our factored form, I'm just going to copy what we got for our standard form. Okay, so this factored form, it's not like a trinomial, but we can still factor out a GCF. So like, what's the biggest thing that goes into -3x squared and 6x? Well, you could pull out a 3, and you could also pull out an x. So I mean, that would just be -x plus 2. Or you could also, if you wanted to, you could pull out a negative, and that would switch your signs. So it really doesn't matter if you pull out the negative or not. It's personal preference. Maybe I'll just pull it out, I guess. But then you're just going to solve each one of these. So I mean, this -3x equal to 0. I mean, you're just going to get x is 0. Or if you pulled out a positive 3x, I mean, you're still just going to get x is 0. And then for this one, I mean, you're either going to have x minus 2 equals 0. I mean, that would be pretty simple to solve. But if you didn't pull out the negative, then you would have -x plus 2 equal to 0, but you'd still get the same solution when you solve. So you should, no matter whatever you pulled out as your GCF, I mean, either -3x or 3x, you should still get these two solutions for your x-intercept. So to sketch this, our x-intercepts are at 0 and 2. And our vertex is at 1, 3. Our y-intercept really is one of these x-intercepts, so we really just have these 3 points. So that would be a rough sketch of our graph. All right, I want to do this next one because we haven't seen this situation. Then maybe I'll have you maybe try that last one before we head out if you want. I'm just going to erase this for now. I need as much space as I can get. So they give us our factored form. So I mean, our x-intercepts would be at -3, and -7. Like if you want to pull those out since they gave us that form. So we want to, like I said, if they don't give you standard form, that's the one you want to find first. So to find our standard form, we just really got to FOIL this out. So this one's actually not too bad. I mean, the FOIL, like there's not a lot of stuff on the outside or anything added or subtracted, so it's not too bad. But that would be x squared plus 7x plus 3x plus 21. So then just clean this up a little bit. So that would be x squared plus 10x plus 21. So if you want, your y-intercept would be 0, comma, your constant 21 in this case. So now we gotta get our vertex form. So we're gonna write the standard form and we're gonna complete the square. So this one doesn't have a coefficient, which is nice. So it'd be x squared plus 10x. Leave a little bit of space. The plus 21 stays on the outside. So 10 divided by 2 squared, well, that would be 5 squared or 25. And then you do the opposite on the outside. So this would really be x plus 5 squared. And then 21 minus 25 would be -4. So my vertex would be -5, -4. And as you're working out these problems too, obviously, like if I had a question like this on your test, I need to see your work of how you're getting these, but you could also graph these in Desmos and you could look, well, hey, what is your vertex? Hey, what are your x-intercepts? So you could kind of check yourself with questions like these pretty easily using Desmos. But like I said, our x-intercepts were at -3, -7. Hopefully I'm not miscounting it. And then -5, -4, 3, 4. So hopefully I'm not miscounting, but it would look something like this. And our y-intercept was 0, 21. So that's not gonna, it would cross eventually up there, but our graph's gonna look something kind of like that. So if you guys want to try this last one, they give you your factored form. Just remember, like that square, you could really write it like that. So basically what they're telling us is we only have one x-intercept, and we're going to see what this means. Oh, this one's actually, I don't know if I don't want to steal your thunder with this question, but you should notice this is also in vertex form already. So you actually really don't need to do this one either, because how they wrote that factored form is actually also vertex form, because technically this would actually be the factored form. Usually want it expanded, but so I mean your vertex is really going to be -4, 0. So sorry to steal your thunder a little bit, but maybe see if you can get it in the standard form. And like I said, just one suggestion, I would distribute that negative sign and then FOIL, but you only distribute it to the first binomial. But see, maybe if you can get your standard form, and then if you have it printed off, I mean, you could see if you could do your graph, but if you don't have it printed or if you don't have graph paper, you don't need to, like, I'm not really that worried about your graph necessarily, just because I'm assuming if you could pull out these points, you all know how to plot points. So that's not really my big focus for today, is not really the graph, but understand what you can pull out from each one of these forms. So let me, all right. But the big thing is when you're finding your standard form, I'm just going to bring over what we had. So we had -x plus 4, x plus 4. Just be careful. This -1 isn't times like this entire thing. Like this isn't negative, like if this whole thing was like around extra parentheses, but so this -1, you're really just going to distribute to one of these binomials. So be careful. That's like a really common mistake. Like every year I teach these. That's like if you're going to make a mistake, usually that's the common one. So now we're going to FOIL. So you would get -x squared minus 4x minus 4x, and then -16. So then we can just clean this up just a tad bit. Combine our like terms. but this would be our standard form. And I've been kind of bad at it, but like all of these forms, it should really be y equals. Like this should have been a y equals up here, but even here should have been a y equals. But most of the time, that's kind of assumed. I mean, so and our y-intercept would be 0, comma. I'm sorry, this got a little bit sloppy. Sorry, that's a minus 16. I think my 1 kind of made that look like a plus. So, I mean, if you sketch this, I mean, obviously the y-intercept's not going to fit on our graph, but our vertex would be at -4, 0. And what that means is like, and that's our x-intercept as well. So this is kind of like a case where it's only going to cross at one spot. 1, 2, 3, 4. So, I mean, the only other thing we could really know is since our y-intercept is 0, -16, it's going to be somewhere down that way. At least I know my parabola is going to open down. So, I mean, for this graph, there's really not a lot of points we have to work with, but you should know your vertex and then at least what direction it's moving, either based on your a value or based on where your y-intercept was. You should be able to at least see. I mean, you could always graph it in Desmos to confirm that. But we are out of time.